Oil table setup part 1. The calculation method for the oil primary values. If you've got a single liquid flowing through your pipeline, you can leave these both set to off, and the meter will take its viscosity measurements based on the medium characteristics. The same thing is true for the density calculation method, if you have that set. If instead you have multiple products running through your pipeline, you're going to want to turn both of these on. This way, you can set the liquid table for each of your products independently. When calculating viscosity, we're going to want to have two temperatures for reference. The viscosity is going to be one value at temperature 1, but a different value at temperature 2. By this method, we are able to ascertain what the viscosity slope happens to be. The reference temperature 3 is for our base values. So in other words, once we take a measurement and the liquid table determines what the density happens to be, it's going to back calculate that to 60 degrees F if you have the meter set in imperial units. For metric units, it's going to be set to 15C. We also have a single reference pressure, and that value is going to be determined by the units that you select, whether it be bar or PSI or a different unit. This menu has the ability to read the oil table values as found, sort those oil table values by numeric entries, and finally to edit the oil table value. Once editing is complete, we can back up the oil table values, or if we need to start over, we can reset the oil table value. Let's take a look and see what's inside the edit the oil table values. Here you can edit a single line. They're in numeric order, so let's start with 1. We have the oil liquidant. Oil liquidant is the measured sound speed corrected back to base conditions. And in the example that we gave earlier, that would have been 60 degrees F and 1 bar. The next field is the liquid identifier. It's there for table sorting purposes. This would be the reference density. So in other words, when a particular product is in the line and we know it to have a particular density, once we know what the liquidant value is, we can associate the density, which has been determined by a lab, and put that in to match the oil liquidant value. The next field you see here is the oil reference viscosity. This would be the oil reference viscosity at the first temperature. The next field is the oil reference viscosity at the second temperature. The coefficients K0 and K1 are the thermal expansion coefficients based on liquid class, and we have a list from which to select these numbers based on hydrocarbon liquid type. Here's the sample of the liquid table like the one that's loaded into the meter when it comes from the factory. There's a list of liquidant values, liquidant identifiers, with different product types, densities and viscosities, as well as the K0 and the K1 thermal expansion coefficients for each product by type. K2 is always going to be set to 0. That's it for now for this particular section of the oil table setup. In the next video, we're going to go through a real-world example and edit the table.